Fantastic. Let's start. Good morning, everyone. It's July the 2nd at 10 o'clock in London. Welcoming everyone to this conversation on digital twins. We have a really healthy number of registrants and attendees to the event, and I'm absolutely delighted to welcome you to the webinar titled Digital Twins for New Nuclear. I'm Doreen Abeysundra, the moderator of the event and the content creator. I thought this is a topic that is a must discuss today. I run Fresco Cleantech Solutions, a financial consultancy which is independently working with technology and project developers to structure and secure bankable financing, whether it's VC, equity, debt. That's what Fresco Cleantech does. A panel of 3 people that you see on the screen right now. I'm going to give them the opportunity to introduce themselves, starting firstly with Victor, moving on to Audrey and Peter. Each one of the panelists, I ask you to give a brief personal background of who you are, your career to date, and how you've ended up discussing digital twins with me here on a webinar. So let's start. Victor, the floor is yours.
Thank you, Doreen. So my name is Victor Richet. I'm currently working in a company named Assystem, but I'm a nuclear engineer by training, and I've been quickly involved in digitalization of engineering processes, involved in deployment of digital solution in a very ad hoc mode for different projects, whether nuclear or non-nuclear. More recently, I've spent 2 years in New Delhi setting up the digital capabilities of our subsidiary in India. And very last, I'm currently heading an engineering program in support of the French nuclear operator EDF, in which I try also to implement some digital transition and digital elements to enhance operations of maintenance for French nuclear fleet.
Brilliant. Thank you for that. And let's go on to Audrey. Welcome.
Thank you, Doreen. Good morning, everyone. Pleasure to be here. So my name is Audrey Goulven Priori. I'm actually a civil engineer as per background. I started my career in the energy sector, working for EDF Group in thermal production and nuclear production for many years, specifically around project management activities. And then I joined the infrastructure sector with a company called Bouygues Construction on large rail infrastructure projects, the extension of the subway in Paris. And lately in my career, I shifted from technical activities to more business development activities, especially in the energy business, still nuclear, and also renewables in offshore wind. I joined Dassault Systèmes, the company I'm actually working in at the moment last year, to lead digital transformation in those specific sectors, being infrastructure and clean energy. So I'm leading a team of consultants supporting customers in those sectors in their digital transformation journey. And I really joined Dassault Systèmes to because I saw an opportunity in digital innovation, especially the virtual twin technology, in addressing the challenges that I've been through myself. So I'm really happy to be here today and discuss how virtual twin can actually be a really game-changing opportunity for this industry. Thank you.
Brilliant. Thank you, Audrey. Peter, if you can introduce yourself, and also for my benefit and perhaps for the benefit of the audience, also pronounce the name of the company that you work for properly, because obviously I'm sure when I say it, I'm butchering it.
Dobré ráno zo Slovenska. Hello everyone from Slovakia, from heart of the Europe. We are at the right center in Europe, and I'm Peter Kertys. I'm head of data science, working at Slovenské elektrárne. That's the name of our company. And we are implementing AI solutions across the power plants. We have nuclear power plants, and I have background in mathematics and statistics. I work in a bank several years as financial analyst and prediction models, and later I transformed during past 5 years into more applied AI for manufacturing and industry, specifically for nuclear power plants. And here I am to talk about digital twin and our approach to find value from the very beginning of implementation of these kind of projects.
Fantastic. That's so brilliant. So I suppose just like you, I'm a recovering banker. I spent a lot of years doing project financing, but unlike you, I don't have that skill set to twin something in your nuclear. So that's why I'm really glad to have you and Audrey and Victor on board, because the aim here is to really give the audience a flavor of what we mean by digital twins and how digital twins relates to the world of new nuclear. And new nuclear, the definition of that is anything to do with SMRs or advanced modular reactors. However, the concept of digital twin does not need to be linked only to a modular project, but as we will see also from large gigawatt scale facilities too. So in this next question, well, what we'd like each of the panelists to do is to please describe your company's role in digital software. For example, how your company uses digital twins or contributes to new nuclear with digital twins. If you can give us a working example and effectively give a layperson's understanding of the technicality of how digital twin works for your company. So let's start now with Victor. Victor, over to you, please. And if you've got slides, please put them on show as well.
Okay, so normally my screen should be shared and you should be able to see it all.
We see it, absolutely.
Okay, so let me start by a few elements about the company I'm representing here today, Assystem. We are an independent nuclear engineering company, provided services. Most of our turnover comes from nuclear industry and is split between France, UK, Middle East, and India. We are about 8,000 engineers contributing daily to those projects, and a rough turnover around 600 million euros. But the key point I wish to underline today is our scope of service is mainly focused on what we call the intelligent engineer positioning, somewhere in the middle of that triangle that you can see right on the screen between engineering, because we are providing engineering studies. I'm talking about mechanics, civil works, etc. Use of project management in order to deliver a plan, etc., and the use of digital, because we believe that this is one of the key transitions that will enable to perform engineering works in a quicker and more efficient way. So the idea is really to be positioned right in the middle of that triangle to provide intelligent engineering services, of course in compliance with safety, ethics, and all those other elements. But if we do zoom in a little bit in digital twin and what is inside, our belief is also that digital twin is far from being only a software or only a platform, and the idea is to work not only on those software and those platforms, but on all the elements which would be surrounding that platforms, to ensure that what is expected from the digital twin is duly specified beforehand. What we would like the digital twin to reflect and to model is as well specified, the business processes, etc., etc. In other words, seeing the digital twin only as one software that will provide some extent of undefined services would be a very restrictive viewpoint, and that links to the positioning I will describe later on. One additional point that is also to be kept in mind is that we do refer to the digital twin as something monolithic, which would be used starting from day one and end up with the same lifetime as the facility. The real world and the real idea, and that is why we believe in this conjunction between engineering and digital twin, is that just as the facility is trying to reflect has its own life cycle, digital twin too has a life cycle, and what you expect in terms of software, in terms of service, in terms of business processes is very different whether you are talking. You were mentioning, Doreen, advanced modular reactor and small modular reactor, which most of them are now somewhere between conceptual design and procurement. So what you expect from a digital twin at those stage is one thing, but that is very different from what you would expect from that same digital twin in construction phase, in commissioning phase, and later on during operation and maintenance or decommissioning and dismantling. All the things you can see in the slide, whereas we are talking about model-based system engineering, whereas we're talking about 3D modeling, all those elements can be constitutive of a digital twin. Are they relevant regarding the phase which is currently there? That is something which is precisely to be defined, which drives me to the role of an integrator, which is the role we are playing in that overall digital transition of our nuclear sector to, on the one hand, anticipate, foresee, and plan those elements that I was mentioning earlier. What would be the roadmap? What would be the expected features? What would be the expected handle data? What would be the expected digitalized business process? All of this is to be written down, clearly identified and shared between all stakeholders. So that will be the initial consulting phase in which we believe as an integrator we can play a key role. Of course, the build phase, implementation and deployment is also very critical to ensure success of the digital twin, to ensure that whatever has been planned in the initial phase is actually delivered using the best in breed technologies. And then in the end, of course, the journey does not stop there, at least for the integrator. And there is a whole bunch of activities which are to be performed in support of the working digital twin, because data injection or data extraction is to be performed. New user will come and go. Of course, new people will join the project, some people will leave the project. So onboarding is to be performed, and administration is indeed also to be performed on a day-to-day basis. So all those elements would be constitutive of the overall digital twin approach and the support we provide as an integrator. Last but not least, because I took note of your request to zoom in to some specific examples. So here are a few of the clients we have been working with as an integrator in that digital twin journey. As you can see, some of them are SMRs or advanced modular reactor, an area, New World, Steady Energy, Nucleo. Some other are working with large-scale nuclear and also nuclear in operation in EDF. I will very quickly zoom in the work I perform as a program director for the 10 years visit program of EDF, where we ensure that all legacy data and all maintenance operation performed on the existing fleet are made and performed in a documented and traceable way using, by the way, a 3D Experience Dassault Systèmes platform to ensure that whatever documentation is produced, whatever requirements are specified, and whatever work is being performed, that is done in a very traceable way, which will ensure later accessibility. And that is, that would be my final word. That is, I believe, what would be the key value of an integrator such as Assystem, to combine, on one hand, in-depth knowledge of the nuclear sector and our customer process, and on the other hand, working knowledge of whatever constitutes a digital twin platform, let it be Dassault Systèmes or some other.
Victor, that's absolutely brilliant. Scene that you've set there for us and given an in-depth on what you're doing. I'm glad you highlighted that point on traceability, and that will be really something I suppose our audience can take away as one of the key benefits, in addition to everything that you've listed there. Let me turn it over to you, Audrey, in terms of what Dassault Systèmes is doing as a company.
Okay, can you see my screen?
I can indeed.
Brilliant. Okay, so I'm representing here Dassault Systèmes, so a technology provider and leader in digital transformation across all sectors of the industry. We have actually a bold and ambitious vision is that the virtual world can extend and improve the real world. That's how it started. And our customers are coming to us being public authority or energy utility or a technology innovator, nuclear innovator, and they're facing the same type of challenges. They really want to ensure energy sovereignty and security in a global and stable geopolitical context. They want to succeed in the climate transition while still maintaining economic growth. And at the same time, they want to decarbonize while still extending the lifespan of their existing assets and increasing the performance of those assets. So to meet these goals, there's huge investments required in new nuclear power plants, in revamping or the existing ones, in the grids, in new green tech. We need obviously industrial workforce, a new industrial workforce that is with the proper skills adapted to the challenges ahead of us. And when we look at nuclear specifically, I mean, often we are speaking of mega scale projects, capital intensive, of course, with very high stakes, large number of stakeholders, high technical complexity, interfaces, connectivities, and people's safety is a priority. And in terms of quality, I mean, there is no margin for errors. So you need to do it right the first time. And this is why in that context, at Dassault Systèmes, we are convinced that the technology, and especially virtual twin technology, is a game-changing opportunity to address those challenges. If we look at the nuclear recent projects, they're still suffering cost overruns and delays. So we definitely need to change the way we work collectively, how we design, deliver, operate, and maintain those nuclear assets. So we think virtual twin technology is a game-changing approach for that. And why do we think that? It's because we've been doing it in the last 40 years. We've been transforming the manufacturing sectors using virtual twin technology. And now what we do is we're bringing the same value into the infrastructure and energy sectors, including nuclear. And what I'm sharing here on the screen is actually just to jump on what Victor has been introducing on what's the definition of a digital twin. And actually at Dassault Systèmes, we don't call it digital. We call it virtual because often digital twin is focused only on a plant or a product and is quite limited to a 3D static model that might be ingesting some real data information, but that's it. Whereas the virtual twin is going much further. It's a science-based dynamic model of an entire system, capturing not only the geometry, but also the behavior, the performance, processes, people, and data that goes around it. And it's constantly enriched with real-world and simulated data, AI, even what-if scenario modeling, which makes the twins an interactive learning environments to predict, what will happen in the future and to take the right decisions. So, for instance, we help our customers in de-risking investments early stage through simulations. We can coordinate across ecosystems from engineering to operations to regulation. We can secure delivery of complex projects by visualizing performance in real time. And we can optimize system-level decisions by simulating this full life cycle of assets that Victor was mentioning. Indeed, the twin is covering the life cycle of those assets. And all of this is powered by our 3D Experience platform that you see on the screen. It's a unified collaborative environment that is on cloud. So we provide sovereign cloud infrastructure at Dassault Systèmes with a SecNum cloud certification for our customers working in nuclear sector or defense sector. And this is really designed for complexity at scale to deliver virtual twin experiences. And if I bring it back to nuclear to illustrate what we do, we are present in that sector for more than 15 years now, partnering with major players like EDF, for instance, working on starting with Flamanville in France, but now moving in the new EPR2 developments and in Hinkley Point or Sizewell C. And actually with EDF, we started with the engineering transformation of the company, and now we are really shifting to delivery. But we are also working with SMR, AMR developers, some of them together actually in partnership with Assystem, like Narea. So they have built a virtual twin of their technology with the 3D Experience platform in 18 months only, which enabled them to validate, to model the complete architecture systems and validate the safety features of their technology. And now they are preparing industrialization and the fleet delivery. We are working also with fusion projects, ITER and UKA in the UK, working with all the players, I would say, in a full spectrum, from very large utilities to SMEs as well. And why? Because the message is that virtual twin is actually accessible for everyone, and we can build a virtual twin of everything for everyone. And our conviction, and the conviction I would like to convey here, is that as the energy transition accelerates, we do think digital innovation is not a nice to have. It's really a catalyst for transformation. So I'm very happy to discuss that further today. Thank you very much.
Brilliant, brilliant. Audrey, thank you. I like that phrase, a virtual world to improve the real world. I might need one myself. So, and let's move over to Peter. Peter, tell us a little bit about what your company is doing.
Okay, so I'll talk from an operator point of view. You can see our cooling tower. And as you can imagine, by different weather conditions, the power performance of this cooling tower differs. And we at the data science at Slovenské elektrárne, we are trying to create predictive models and statistic analysis to find the optimal setting of these parameters. So Slovenské elektrárne is a major electricity producer in Slovakia. We have 2 nuclear sites with 5 operating reactors, and 6th would be commissioned next year. And overall in Slovakia, there are plans for building a new SMR and also large power plant, but that's the future. Currently, we are operating these power plants, also water power plants and some photovoltaic, and we are covering more than 70% of Slovakia production, and totally we are among the Financial Times global leaders without CO2 emissions. What do we understand by digital twin? It's a range of solutions which could help optimize internal processes from an operator's point of view. And in the future, the digital twin should have all these 3 aspects which are mentioned here, like language models, statistic models, and physical simulation in one solution, one connected environment. And there are many companies which offers this, as you could see already. Here are some projects which we already delivered: internal consumption optimization, AI summarizer, or chatbot on internal documents. And we see that for engineer to properly operate the power plant, the vast amount of knowledge which he has could be enhanced by assessing the information in proper context. For us, the digital twin means not only simulation or 3D model. It means to put all these things together. And we are internally trying to create some environment which could enable this. For example, for the optimization project, which is mentioned here at the lower part, we are optimizing the secondary circuit optimization by proper adjusting, for example, impeller blades. And by this project, we have saved last year 2.7 gigawatt hours of energy, which is around 1,000 homes consumption yearly. So there's an example what could this digital twin brings into the company, specifically for power generating companies. A small optimization in a nuclear power plants, like change in 0.1% leads to large energy savers and also the revenues. So this is what I like on my job, that we do small statistics, sometimes almost insignificant, but due to the power and the prices, it at the end makes a huge impact on a better society, or for the environment, also for the revenues. So this is from our point of view.
Just small statistic, it is not, Peter. That's just such a fundamental difference that you're making. I made a note here, 2.7 gigawatts of electricity saved specifically from the work you're doing. That's just a fundamental contribution, not just only, as you say, to the carbon emission reduction, but also to financing. And that's a brilliant segue to the next question that we're going to be addressing with the panel. Obviously, we are aware of the gigawatt scale financing needs being gigawatt themselves. Audrey, you talked about cost overruns that we've been seeing and delays. And from a consultancy perspective, and being an ex-banker, as all of you know, investors and lenders want certainty. They do not like change. I remember too often having to go to credit and sit there going, oh, the financial model has changed. The projections are changed. The CapEx has changed. Does not make for great conversations. So now my question to all three panelists, using what you do within digital twins, specifically for your company and for what you produce and deliver, how do the digital twins either replace the physical pilot plans for investor due diligence, or do they complement it, or generally, how can the investors rely on the validity of the digital twin, its existence, just to help them put together a financing that is so-called bankable? And let me start with you, Audrey, here.
Thanks, Doreen, for the very good question. When I mentioned the use of virtual twin in an early phase of development, actually de-risking the investment is part of the added value that I think the virtual twin can bring, and what we are already providing to customers in developing low carbon technology. Because of the uncertainty that you mentioned, and because of the need to understand having good predictions and what the future would look like in all the aspects and dimensions. So not only from the development side of the project, engineering, construction, but also, of course, in terms of maintenance and operation. So because the twin can predict this behavior in all across the life cycle, it helps really understand what the expectations would be in terms of global performance, including the financial one. So today, for instance, if I take the example of offshore wind developments, which is anyway similar to any large low carbon technology projects, we can run simulation with the twin on LCOE cost, okay? But this LCOE is attached to a system understanding of the project, including not only the technology aspect, but again, the ecosystem around it, the supply chain, the companies, the interfaces, all stakeholders that will be around it, and how they can potentially impact the development of the project and the future asset in operation. And I think it's all about de-risking in a very early stage, and being capable to demonstrate to investors that we have a very high level of confidence on the hypotheses that are taken, because we've simulated scenarios, because we have not left, gray areas aside, and we've explored the potential of opportunities that is ahead of us.
Brilliant. And Peter, if I can go to you from your perspective, you brilliantly pointed out how there is a reduction of carbon emissions, for example. But maybe from an operator's perspective, how does the word financing, digital twins, and bankable come together for you?
Yeah, we see a very big opportunity to enhance efficiency, specifically for older power plants, which we have, some of them, and not only for existing installation, but also with adding new measurements. You are now able to compute things which usually were run once per month. Today, we are able, with online measurements, recalculate the expected outcome, for example, some steam pressures or enthalpy on those kind of things, directly, like every 10 minutes or every 5 minutes or even every 10 seconds, if you like. And by adjusting and selecting these results and comparing them to the design behavior to digital model, you will find several discrepancies. And you could start understanding your asset better. Is it some maintenance issue, or is it bad operation? Is some armature leaking? And those kind of things you could find and identify using this digital twin approach. And we are combining the several statistics methods together: physical simulation, basic design document, and also the actual measurements. And sometimes one may try to fit for the actual status of technology, but that's not enough. I see the value of digital twin not only proper modeling the reality, but also what should be the reality, because the devices degrade in a time. So something you model today, in a few years, you will have different results. And you may think that if you have auto learning models, it will adapt to the degraded condition, but you still need to go to the basic design expectation. And this may help also the investors to find the value that not to compare only for the reality, but also what is to be expected.
Thank you. That's incredible. Thank you. And Victor, over to you.
On my side, well, I'd say for me the key point has already been summed up by Audrey. We all know that nuclear project can be very, very lengthy. And when you increase the length of a project, subsequently, and for obvious reason, you increase the risk that may occur during design phase, during construction phase, during commissioning phase, etc., etc. And when you increase the risk, of course, you increase the total cost of the overall facility, of the overall infrastructure. So for me, one of the key benefits that can be brought by the digital twin is indeed to acquire better and enhance visibility of what may occur in the future of design, in the future of construction, etc., etc. And for obvious reason, when you increase the visibility, you increase the control and you decrease the risk. Let me take two specific examples for illustrate that, in which I think digital twin can improve. We all know that most of the time nuclear power plants come by pair or come by some number. So the use of digital twin for replication purposes to ensure that whatever has been built, for example, in Flamanville 3 will be replicated in HPC, or whatever has been built I don't know, as SMR or in India or whatever can be replicated. That is a key way in which the digital twin can be leveraged to decrease the risk occurred by a new construction, and subsequently to provide more certainty to bankers or financiers in general. Another one is, we all know that nuclear projects are very subject to design changes all along the way of their design phases and construction, etc., etc. Well, by using digital twin, perform sensitivity analysis or what if scenario, we also increase the level of certainty regarding the impact of those engineering changes, and once again subsequently decrease the risk of a design change, or at least the risk of them having a very adverse impact on the financing scheme, subsequently making nuclear projects becoming, in a way, more bankable. So I think well, I am not convinced that in a very near future, a digital twin will replace actual facility or prototypes, etc., etc. But I am convinced that they will at least partially replace them and provide key value, reducing to the strict necessary the amount of time that need to be spent on prototypes and so on and so forth.
And Victor, if you allow me to jump on that, about the prototype and need of prototype, of course, that might not happen tomorrow because, again, the sector still needs to transform, and in terms of maturity is not at the same level than other industries. But if you look at manufacturing sector, if we take aerospace industry or automotive, in aerospace, I mean, there's no more real prototype, built before a plane is sent in the sky. So we can imagine that if the sector is transforming to that level where we have embraced the capability of virtual twin and maintain this virtual twin as a virtual asset of the plan as much as we invest in the real one, we can, I think, assume that maybe in the future we won't need any more those prototype or real prototype and completely use the virtual world to address and secure all our challenges and questions.
That's a really useful example to compare what we've achieved in the aviation space with what we're doing in a new so-called new environment with the nuclear industry. I think this would be a good time for us to take a question from the audience members, and I'll pose it to each of the panelists, starting with Victor, then Peter and Audrey. The question is, do we see these models, I suppose the digital or virtual twins, as we've also learned, running through operations and into decommissioning and dismantling? Victor, how about you share your thoughts there for maybe a minute or so?
Well, for me, very clearly, on one side, it's something which is very much value bringing, being able to capitalize on whatever has been built in design, enhanced in construction, reinforced in commissioning during operation and dismantling phase is something which would be of utmost value for the operator. But one key point needed also to keep in mind is that the landscape in nuclear project can be quite crowded. There is a whole lots of stakeholders around, let it be the nuclear regulator, the operator, the designer, the vendor. All of them might not be the same. So we are facing, let's say, a structural issue in the way that the one developing the digital twin or the virtual twin for design might not be the same entity which will be operating the plant. So that needs to be thought of in the very early stages of the contractual scheme in order to ensure that capitalization would occur all along the power plant's life cycle, regardless of whomsoever is contractually binded or responsible for maintenance of that. And as far as I have seen in the project I have had in my perimeter, that is a key point which is quite often overlooked and not secured early enough in the design or in the project.
Helpful, really helpful. And Peter, from an operator's perspective, do you see the digital twin, being of use? And I know you've already mentioned it, but all the ways from operations through to decommissioning and dismantling.
Yeah. I've seen some use case to predict the estimated time of radiation decrease during dismantling the nuclear power plant, and this could be done using the digital twin technology, like modeling and those approaches. But I would like to mention that the pace of new emerging technologies is so fast that it's almost impossible to predict what we will be using 10 years ahead, not even sometimes 5 years ahead. there will be new technology. We've seen the rise of AI today, mainly for chatbot, but AI as general could suggest in the future a new, better way of approach to this part of the operations. And there's also many companies which are already developing new power plants using AI and generative design, and going through many iterations of models and finding the proper architecture. And the simulations which cannot be done in the past, now they are here. And in a few years, I'm sure there will be new technology which will enable to do things much faster and much more reliable. And I think in nuclear industry, this is what we need to stress, that always these solutions needs to be secured and in a safety manner and properly validated and verified to bring actual value and not just to run for the best new thing. And these things need to be verified and not use everything. Sometimes the last thing I want to say, the most simple solution could be better than specific models. And we found this during one of our optimization projects. We ran many analyses and computations, and final decision tree was only used, which is very, very simple. It's not very common. So,
Peter, I think you've addressed the so-called elephant in the room, the fact that AI and where the world that we live in now is moving so much faster than we could possibly have ever imagined. Yes. We're in almost a paradigm shift where, the shift is happening before we even define the paradigm, so to say. Audrey, give us an example from your side on how virtual models are being used in operations and all the way through.
Yeah. So as I said before, and as Victor has been mentioning as well, we are currently supporting customers and owner-operators on their existing nuclear fleet, optimizing the global efficiency and especially all the maintenance cost. And so this is already happening. And I think what has been a game changer in how the virtual twin is delivering value from design, again, until operation, dismantling, really the full life cycle of the asset, is thanks to the development around data science and AI. Why? Because on existing fleet, I mean, most of the information is often paper archives, that have been locked in the cupboards on the fleet, and you've got all this pool of information there. And what do you do with it? And our approach as Dassault Systèmes is really managing the complexity of this data for our customers and preserving this IP that they have, which is very connected to sovereignty, and creating new IP with the virtual twin. And with data science and AI developments, you have the capability now not to bring all the documents in one single virtual library. That won't probably help you better to understand where should I look at and where is the information that I need, rather than having a very data science AI approach, which is about creating ontology and semantic graph that will help you look for the data that is key for you for your performance indicators that you want to follow up, and aggregate this data in the twin, transforming this into contextualized and actionable insights. And that is a shift in terms of mindset. I think that the sector needs to have as well. We don't need shift from document-centric to data-centric, and I think this is something that more and more we will see through the ecosystem. And just one last thing I would like to add to Victor, a comment I fully agree with, is about the complexity of the ecosystem, especially around nuclear. And yes, of course, players are very different, and they often intervene in a very specific part of the life cycle. Again, the virtual twin should allow for an extended enterprise collaboration as well, because it can connect those different players that intervene at different moment of the life cycle to make sure that the twin is initiated in an early stage and is fully available in operation.
Got it. Very helpful. That extended collaboration is indeed a brilliant way of considering our next question as well, when it comes to a regulation perspective. But before I do that, if maybe I can ask Victor to just give maybe in a 30 seconds, if possible, a quick answer to one of the questions that's come in from the audience, the challenges that you have faced in terms of creating a digital twin. If you can do if you can just address that very quickly, and then we'll go into the question on regulation.
Well, I'm going to be very quick in my answer. Technology is usually not a problem. Basically, whatever is specified can often be done, but the key point is to get a clear view of what is specified, wanted, or expected. In other words, it's quite often more challenging to know what to expect from the digital twin than to actually develop it. And that is why those early phases of specification of need, roadmap, etc., are often overlooked, yet they are very, very critical.
Right. That's so helpful. And maybe Peter, then if I go to you first, in terms of our next big question is effectively, how is your company liaising with your home nation's regulator or, with international regulators, if at all, to form this extended collaboration that we've heard about already, and even setting up the roadmap that is critical, as highlighted by Victor, in a couple of in a minute, please.
Yeah, there's a very strong regulation in nuclear industry overall, and there are all well-established processes to standard software to validate and verify. However, with the AI, there is a need of creation a new approach, a new paradigm. And I'm involved into International Atomic Agency writing the document safety consideration of using AI in nuclear installations. And we are discussing with other experts from around the world the experiences and specifically the human factor interaction. So this is something what needs to be addressed in the future. We still do not know the current position, but it's preparing. There's many discussions going on. And the second thing I would like to say is the AI Act, which is applicable in the European Union.
Yeah.
And specifically, it requires to monitor and to have information about all AI solutions you are using in your company. And by AI, I do not mean the language models. I mean everything what seems intelligent. So even all the software models now can come under the AI frame, and we need to monitor the stability and the usability and the users, how these tools are used, and if they are not in a restricted category. There are several levels, tiers of applying this AI Act based on the criticality of the solution, like critical infrastructure, faith on a human, and like these kind of things. So okay. I think the regulation could slow her down, but for the better safety, it is needed somehow.
Okay, brilliant. Thank you. And if I pose the same question to you, Victor, and then Audrey, bearing in mind we just have a couple of minutes for this question. Oh, Victor, you're on mute.
Sorry. So yeah, whether we wanted or not, nuclear is a heavily regulated industry. I was about to underline as well the effect of the AI Act and its impact of whatever development that might be done. But well, the other side of the coin is that each country has its own nuclear regulator. It's the NRC in the US, the ASN in France, the ONR in UK. Please forgive me, Peter, I forgot the little name of the safety authority in Slovakia. I used to know it, but I
Peter,
can't
maybe you want
remember
to
it.
just give the name?
UED.
Yeah, the name of the regulator in Slovakia.
So yeah, and we are heavily dependent because, of course, the safety regulator expect the operator and all its stakeholders to provide the proof of the safety of the nuclear power plant or whatever nuclear facility is there. So we are also heavily dependent on the capability of the regulator itself to accept those new means of proof through virtual twin, digital twin, computations, might be in the future through the use of AI. And well, as long as those way of proof are not validated and approved by the regulators, the impact of digital transition and digital twin in the nuclear industry will remain related to non-safety related issues, which is, let's say, the tip of the iceberg, but not the core of the iceberg.
Thank you. Audrey, what are you doing with the regulator? And I'm just conscious, all of you are within the EU, so perhaps for the next conversation, we'll need to get members of countries that are no longer or have not been in the EU. Yeah,
definitely. What I wanted to say about regulators is that they are also seeing the value of the virtual twin. Even if, of course, they will have a lot of they have questions about the conformance, all the traceability, you know, and all this demonstration around safety that is still expecting. And actually, what they find in the virtual twin is that level of traceability. And a good example that has been implemented with EDF, for instance, is what a project which is towards the French regulation on nuclear pressure equipment was the interaction of the nuclear authority, French nuclear authority, ASN, and basically the twin was allowing OEM to place all the information and files demonstrating how the equipment was meeting the safety requirements. With all the visual about the equipment, the traceability, again, on requirements, and because the twin was allowing for, you know, showing the truth of the proof of the demonstration that the requirements were met and how they were met. Through the digital continuity, through the traceability that is allowed by the twin. I mean, the nuclear authority was really interacting with the technology and finding value out of it. So I think we will go more and more into this use cases involving regulators that have a great role, again, in understanding the level of safety that all the ecosystem is providing in developing nuclear assets. The other thing I would like to mention, another added value about the technology, is regarding configuration management in terms of when you will have a fleet of SM or AIMR to deploy across different countries, you will face different type of regulations. And we need to tackle that at some point. I mean, we need to bring a level of standardization, at least at European level, so that maybe 80%, you know, the requirements are more or less the same, and 20% could be specific. And here again, the virtual twin can help navigate those different environment, geographical environment with their specificities, and deal with the configuration management aspect that would be required when we speak about industrialization of the fleet.
Mm-hmm. I can't help but be devil's advocate here, Audrey. Doesn't standardization stop competition and creativity?
If standardization stops it?
Mm-hmm.
No, and if we listen to the nuclear industry, and I mean the audience here might testify about it, but people are requesting standardization. because this is the way that we will optimize the cost. We cannot deal with a first of a kind every time we build a nuclear project. If we want to scale up and again reduce the cost and delays that are associated to this industry, unfortunately, standardization is clearly a way, even from a fabrication OEM point of view, that they want to pursue for sure.
Brilliant, brilliant. And I'm going to note that we also have a question from the audience about the significant proportion of new build capex that's being spent on geotechnical engineering and foundations. For example, with regards to the infrastructure needed for heavy foundations. So I suppose that we might need to have a conversation on how the virtual or digital twins helps with the capex beyond the capex of the physical plant in itself. So perhaps, feel free to incorporate that in the answer that you want to give for this last question. We have 4 minutes between the three of us. So in terms of what's the most significant use case or change in new nuclear, which you're expecting, which involves digital twins or virtual twins? Let me start with Peter, Audrey, and then Victor, you'll have the final word.
Maybe I'll say a vision of 50 years ahead. I know that there's autonomous nuclear reactors in development, and I think it could not be done without a proper simulation and all virtualization. So I see in the very far future that there will be on remote locations autonomous reactors supporting data centers, and which currently is a very big topic. So it's for me.
Brilliant. Audrey?
I would like also to talk about the need of a vision and an ambition towards the virtual twin technology and embracing that technology in as a catalyzer of transformation in nuclear industry. Because again, it's not an experimental technology; it's a well-proven technology. So even if this industry is quite risk averse, this is not experimental, but this has been given proof in the past. So we should really start this transformation process. And we need to think, again, at the level of the ecosystem and how can the virtual twin can really reconnect the dots in between this level of complexity. And maybe, last word, not trying to keep the existing processes and trying to find the technology out there that is going to match our existing processes, but maybe rethink the processes in line with what the technology can actually offer, especially when we think data-centric, data science, AI. I mean, this is a unique opportunity to revamp the organization, also to be more efficient.
Brilliant. Victor, what is that significant change that you're looking to see?
Well, on my side, I will be much more pragmatic than my colleagues. I think anyway, nuclear industry will have, and I hope so, lots of projects to deliver in the coming decades. And whomsoever says more projects says more workforce. So I think one of the key challenges to be addressed with the help of digital twin and with the help of AI is to ensure knowledge transfer from one generation to one another. That would be some kind of existential challenge, because if we don't manage to do that and to ensure that the knowledge is transferred, we will not see the increase of productivity which is needed to deliver those projects. It can be AI as basic as ChatGPT for nuclear and question and answer. It can be much more advanced mechanism, but that would be for me the, let's say, critical point of our journey that we need all to take into account.
This has been such an insightful conversation. I think we have whetted the appetites of the audience so that we need to have a further in-depth conversation. So much said, but 3 key words that came out were reality, feasibility, vision, and we all agree that this is an existential change. We're effectively in that paradigm shift. I thank you so very much, Audrey, Victor, and Peter. Thank you.
Thank you, Doreen. Thank you, everyone.
Thank you very much.
Thank you, Doreen. Thank you, everyone.